Good evening, ladies and gentlemen. My name is John Agudelo, and I have the pleasure of introducing my teammates, Michael Tran and Aloma. And together we will be presenting over the most common contemporary HVAC systems for comfort cooling of large establishments. Now, a little background on HVAC. First off, it stands for heating, ventilation, and air conditioning. And its purpose is to provide comfort cooling and heating. Now, heating and cooling have been around since the dawn of time, and it has moved from its more primitive, creation of fire to the more modernized ways that we have now. Now, these processes are based on the laws of thermodynamics and fluid mechanics, which were developed by Sir Isaac Newton and his fellow scientists. There are 4 different types of HVAC, and each pertain to a certain application. The classical heating AC split, which is for industrial, the hybrid heat system, which is the more efficient version of the other, the duct-free heating AC system, which you will most commonly find in your vehicles, and the package heat AC system that you find in your home. Comfort cooling of large establishments. The most common type of system found, the heating and AC split, and is powered by electricity. Now, some design considerations to take into account would be the size of your establishment. You don't know how complex the system needs to be or how many fans or components that you need for the size of your building. There is the budget, how much you're willing to spend, and you must take into account maintenance fees and all costs. There are safety hazards. Such hazards can be exposed piping or airborne bacteria. It's a hazard. There is comfort. The more comfort that your workers have, the more productive they can be, and the activity inside the building, which is the generation of heat.
Evening. I'll be going over the heat portion of HVAC. There are 3 main types of heaters out there: boilers, furnaces, and heat pumps. Heat pumps being a more efficient form of boilers. And they transport heat through the systems, through pipings and then the exhaust, within the ceilings, walls, and floors. Some applications for these heaters is creating hot water from boilers and heat pumps, and for purposes of cleaning and cooking. Warm air is created by furnaces and again circulated within the building. One thing to mention about these furnaces, though, is that they use fossil fuel as a fuel source, and thus creates carbon dioxide and carbon monoxide, which can be very lethal to the occupants. Best way to handle these issues is proper ventilation systems and/or filtration systems. Ventilation is the process of air distribution and air quality control. There are 2 main types of air ventilations: mechanical and natural. Mechanical air ventilation system is pretty much a force-induced airflow created by ceiling fans or exhausts and can be controlled through a central unit called an air handler. While natural air ventilation system is using the outside environment to help circulate the air. One additional benefit of a mechanical ventilation system is that they can also control temperature. One downside to that, though, is that they are poor air quality control, as they're very poor at circulating the airflow. While natural provides a better form of air quality control, as they use natural air to blow and exchange oxygen levels and clean up the air within to prevent airborne diseases and pathogens. Air conditioning is pretty much providing cooling as opposite of heating. It's based off the refrigeration cycles of thermodynamics. There are 4 main components of this refrigeration cycle: the evaporator, the compressor, the condenser, and the expansion valve. Let's start with the evaporator. The evaporator's main purpose is to convert the coolant or refrigerant, such as freon, into a gas form. And thus its purpose is because the compressor cannot compress liquids as they are incompressible, and thus has to be a gas. The compressor then pushes the gas to the condenser, and at the same time help cool it down, making the condenser easier to convert the gas into a liquid, which is also our coolest part within our cycle. The liquid then is circulated within the system to extract heat from the surrounding environment, and then goes into the expansion valve. The purpose of the expansion valve is to create a high pressure and low pressure for the liquid to propel back to the evaporator.
So how does air conditioning in a large establishment work? Well, you have one very big cycle that's composed of two smaller cycles, the closed loop and the open loop. The key component in this cycle is the centrifugal chiller. Now, as my colleague mentioned, air conditioning is just a basic thermodynamical refrigeration cycle. Now, that cycle all happens in here, in the chiller. So, the chiller sends chilled water into the air handler of the building or the site, whatever the application may be. Now, once the chilled water is in the air handler, you normally have like a fan blowing on the tubes that are located within the air handler, and that's what creates your cold air. And then that cold air gets dispersed throughout the whole building. That chilled water then comes back into the chiller for cooling. Now, because the refrigerant is cooling water, it in turn is picking up heat. And that is where the open loop part of the cycle comes. Because how do you take the heat off the refrigerant? Well, you have condenser tubes located within the chiller that the refrigerant comes in direct contact with. The condenser tubes have cold water flowing through them. And when that water picks up heat from the contact of the refrigerant, it is sent to the cooling towers for cooling. Now, in the cooling tower, the water will drop about 10 degrees Fahrenheit. So let's say it came in at 70, it'll leave at 60. Because cooling towers are typically located outside, and because of the way they're designed, 70 to 80% of the water that comes from the chiller to the cooling tower will be lost to evaporation. These cooling towers, however, are built with a makeup water line in order to combat that issue. The cooled water from the cooling towers then will return to the condenser tubes of the chiller, and the cycle continues as one whole continuous cycle. So, future improvements of modern HVAC systems. Let's take the chiller to start. Chillers are all about efficiency. How much cold water you're producing versus how much power you're inputting. Scale and corrosion are the biggest problems that the chiller experiences because calcium carbonate, which is scale, builds up on the wall of the chiller and inhibits the heat transfer surface when the refrigerant comes in contact with it. This means that the chiller has to work X amount of times as hard to produce cold water, thus drawing up more power and increasing your operation costs. The proposed design to improve this issue is to create condenser tubes that are scale and corrosion resistant. Now, cooling towers, on the other hand, have a problem with bacterial growth. Legionella is the bacteria that causes Legionnaire's disease, and that's very commonly found in cooling towers. The proposed design to combat that issue is to make the cooling towers out of a material that inhibits bacterial growth. Now, a very big problem in the air handler of a building is the production of mold and mildew. Air handlers are located in places in the building that are dark, cold, and wet, which is a perfect environment for mold, mildew, plant spores to just thrive and get inside your system and disperse throughout the whole building. That's something called sick building syndrome, and that can have a very, very big effect on the health of the inhabitants of the building. So in conclusion, HVAC systems undoubtedly need improvement. Why? Because we want better efficiency from our chillers, so we can lower our operational costs. We want a safer environment for everybody. We don't want sick building syndrome. We want everyone in the building to be as safe and as sound as possible. When these two things are combined, the quality of life increases and operations just go so much better. Thank you so much for your time and have a great day.